Well, thank you very much for coming, and I'm very glad to be here to present this course. And in this lecture, I will introduce you what a recommender system is and what are the different technologies we have to develop a recommender system. So perhaps the first question we should ask ourselves is what a recommender system is. And obviously, we can say that a recommender system is a system that provides recommendations. However, this definition is not very precise, okay? But because not all systems that provide recommendations are considered as recommender systems for researchers. So, for example, when we deal about a system that recommends us company stock to buy in the stock market, this is not considered a recommender system for researchers, because this is a system that needs to predict very well, very accurately, the values in the stock market. So another kind of system, for example, to provide recommendation about the treatment in an illness, is not considered a recommender system for researchers. So recommender system try to provide recommendations about items that users consume, okay? Try to predict the user's taste. Okay, so in our recommender system we have users, registered users, and that consumes items according to their taste, and the recommender system provides recommendation about these items to this user, okay, according to a database in which we store information about users, about items, about the feedback of users to the items. So this recommender system is indeed an intelligent system. So when we develop recommender systems, usually use techniques like machine learning. Okay, indeed, when the recommender system has been developed, many specific techniques have been also developed, okay, from machine learning. So here we have a lot of examples of recommender systems, and I would like you to think about three kinds of recommender systems. Okay, we will take into consideration this kind of samples when we think about a recommender system. For example, it's very typical to speak about movies in recommender system. So when we want to develop our recommender system on movies, we want that the system provide recommendations on movies. For example, in this slide, it's here providing recommendation about movies. I suppose that you know this Godfather. I don't know Indian films, so I have to put examples of European or Western films. So, well, this is the kind of example of a system that provides recommendation on movies. Another kind of recommendations or recommender system could be based on news. Okay, we want to provide recommendation on the latest movies, latest news for users. Or for example, we want to develop a recommender system on music. Okay, we want to provide recommendations on songs to the users. Okay, just consider these three examples because there are different kind of recommender systems. In movie domains, for example, here we use, I will give you three examples. Two of them are very, very well known in recommender systems. One of them is Netflix. Okay, it's very famous, the Netflix prize on recommender system. And another is Film Affinity. We have developed in Spain this recommender system is very famous in Spain. And another one which is very used for researchers is MovieLens. Okay, but you can search in Google MovieLens and you can find it. So in new domains, we want is to recommend news, okay, to users, and in music domains we want to provide recommendations about songs. Okay, these three kind of examples for recommender systems. So, in this lecture, we will ask 3 important questions. The first one is, which information do we use to make recommendations? Okay, which is the database. The second one is how to implement a recommender system. And the third one is how to evaluate a recommender system. In relation to the first question, the kind of things that we can store in a database is things about items and about users. And about items, we have different features of each item. For example, in this example, we have information about the director or the running time, or even the plot. And about the users, this is called content-based information. And we have information on users, for example, the gender or the age or the profession of each user. And this is called demographic information. Obviously, users provide feedback to about what he likes. So, for example, a user could say that we'll evaluate an item with a rating, typically is with 5 stars, stating if the user likes or how much he likes an item. Another way to provide feedback is observing that the user has consumed an item. Okay, this is also another way to obtain feedback information. So we have 2 different kind of feedback. We have explicit feedback when the user rates an item, or implicit feedback when the system observes that a user has consumed an item. And now we have other kind of information. It's called social information, because when users are friends, they usually share their taste. So we have another source information called social information. So this is the most important source information to store in the database. About feedback, we can store it in these 2 tables, okay, ratings or consumption. And now there is another important kind of recommended system called context-aware recommended system that includes more features on the ratings table. For example, time, weather, when the user consumes it, because the context is important for making recommendations. So this table can be extended in this way. We have also information related to the content of items, which is stored through a table like this. And we have information of demographic, information of users. So we could store this information in a table like this, users. Okay? And relation of users, friendship, for example, can be stored in this kind of tables. So finally, we have these tables to be stored in the database. So according to the tables that the system uses to predict the taste of users, we consider 2 kinds of recommender system. The collaborative filtering-based recommender system and the content-based recommender system. The collaborative filtering recommender systems uses only 2 kinds of tables, the ratings and the consumption. Indeed, they usually use only one, ratings, okay, or the consumptions. The systems use only the feedback information provided by the users. So we have this kind of the database is stored with these 2 tables, and the system provides recommendations. And when we talk about collaborative filtering-based recommender system, this is usually represented by means of a table or means of a matrix. okay, in which each row represents a user, each column represents an item, and the cell indicates the rating of the rating that the user has made of the item. For example, here this indicates that the user U6 has rated the item E7 with a rating 4. And as you can see, there are many cells that are empty. And indeed, this matrix is very sparse. It's much more sparse than in this example. So because the user only rates very few items. So we represent with this symbol, with the point symbol, that the user has not rated an item. It's very typical to have another kind of explicit feedback like this, which indicates if a user likes an item or if a user dislikes an item. So in the same way, we have a lot of cells that are empty, so because the user has not rated these items. When we deal with, for example, music domain, instead of having explicit information, it's very typical to have implicit information in which we express the number of times that the user has consumed an item. For example, here we say that the user U6 has listened to the item I7 14 times. And here we have a lot of null values in this table. Instead of not having empty cells, we have here null values because the user has only consumed a few items. Okay, this is the kind of input we have when we deal with collaborative filter-based recommender system. When we speak about content-based recommender system, the database has mainly two important data tables. One of them is related to items, and another is related to the consumption of the users. We have another table called users profile, in which indicates which is the kind of things that the user like. Okay, in these features, as you can observe here, these features are related to the items. So we have here two different kind of recommender systems, and we are going to compare both approaches. Okay, we are now talking about the cold start problem, and we are going to speak about what happens if a new user registers the system. So just imagine that we have a new user that is registering the system. So, and we want to provide recommendations to this user, to this new user. So the problem is that which kind of recommendation we can provide. Just imagine what happens when we deal with collaborative filtering-based recommender system. Here we have this input, so we have this table, which is equivalent to this matrix. And so we have here a new user. The recommendations we need to provide are based on this table. So what kind of recommendations can we provide to the user U12? Well, we cannot provide any recommendations because we don't know the taste of the user. So it's impossible for the system to provide personalized recommendations to this user. And what happens to content-based recommender system? Well, we have here that in this database we have items and we have the user's profile. And when the user registers, the user informs about their taste. So just imagine that this user likes crime films. So here now we can provide recommendations because The Godfather film, I don't know if you know it or you have seen it, is a crime movie. So we can provide recommendations to this user, to this new user. Okay, so an important drawback of collaborative filtering-based recommender system is that it suffers from new user cold start problem. We have another problem related to cold start, which is called the new item cold start problem, is that imagine that we have here a new item. Okay, there is a new item, we register in the database, so we want to know if we can provide recommendations to the users. In collaborative filtering-based recommender system, again we have this input, which is equivalent to this one, and we have included a column, an item, representing the ratings that the user have made to this item. However, this item is new, so any user has provided any rating to this item. So this item cannot be recommended to any user. What happens to content-based recommender system? Well, in content-based recommender system, we have that there are two tables. We work with two tables to predict the taste, the user's taste. And here we have that we can recommend the film, this new movie, because we have information here about this new item. If a user likes crime films, we can recommend it. So the collaborative filtering-based recommender system has the drawback of suffers the problem of the new item call-start problem. However, a content-based recommender system has another important drawback, which is much important than the others, which is that these kind of systems provide always obvious recommendations to users. Users don't evaluate well these kind of recommendations because he perfectly knows that he will like these items. So there are obvious recommendations, and the recommender system is not useful for users. On the other hand, collaborative filtering-based recommender system provides more novel recommendations to users. So here we have in this slide the drawbacks and advantages of these two approaches. The first one, collaborative filtering-based recommender system, suffers from the call-start problem, but provide interesting recommendations to users. On the other hand, content-based recommender system, although avoid call-start problem, they usually provide obvious recommendations, and in this way they are not very well considered by users. Okay, so now we have the hybrid approach. We try to take advantages of both approaches. Okay, so real recommender system uses this kind of approach. However, in research, we usually work in collaborative filtering-based recommender system and in content-based recommender system. Okay. So we have answered our first question about which information do we use to make recommendations. Another question is we have here is how to evaluate our recommender system. So, and here we have that we can evaluate the recommendations that the system provides for different features. The first feature, the accuracy of the system, is try to answer the following question if the user likes what the recommender system recommends him. This is the accuracy. The system predicts the user's taste well. We have another kind of issue we need to answer in the recommender system is about the diversity of the recommendations. We need that the system provides always different kind of recommendations, because if we concentrate all recommendations in one kind of item, this user does not evaluate well this kind of recommendations. Okay, we need to take care of the mood. It depends on the mood that the user consume an item or not. For example, in songs, when in some domains, perhaps now I prefer listen one kind of music, and then perhaps I prefer to listen other kind of music. So you need to provide different kind of recommendations in order to satisfy the user's taste. So it is well considered when a system provides different kind of recommendations. Another issue we should consider when we develop recommended system is the trust that the users have to this recommended system. So we need in some way to explain the recommendations that the system provides in order to convince the user that these recommendations are good. And we should include in some way reliable measures, reliability, that informs the reliability of the recommendations. And another important question is about serendipity, is to provide novel recommendations, items that the user don't expect, but they like. So our recommended system is very well evaluated when the system provides important, not obvious recommendations and that the user don't know. So here is the second kind of recommended system. Excuse me, so the second issue we have asked about recommended system. And the third question we should ask is how to implement a recommended system. Okay, well, there are many different ways to implement a recommended system. It depends on the domain, it depends on the kind of recommended system, but all of them has the same philosophy to develop a recommended system. Is that we have a database, we have a user, and we have a function, a process called matching function, in which we have this function scores a value for the user to this item, indicating how much the user likes this item. Okay? So what we do is to obtain all the items in the database and calculate the matching function for the user to obtain the score of this item for the user. So, and do it again. Okay, and when we have calculated all the scores for the item, all the scores of the items for this user, then we have a filtering process to obtain only the highest items with highest score. Okay, so this filter select items with highest score, and this one provides additional constraints depending on the domain, generally. For example, if we want to implement a recommended system about restaurants, we have to provide additional constraints. For example, here I live in Spain. Now, if I want to provide, if we have developed a recommended system on restaurants, the system should recommend restaurants on India, not on Spain, because I'm here now in India. So when we calculate the scores here, we only calculate the scores for some items in the database. So this is more or less the architecture of the recommender system. Okay. The most relevant process in this the system is the matching function. So it depends on the domain, and it depends on the kind of recommended system. Indeed, we have considered two kinds of recommender system according to the matching process. The first one is called recommended system based on memory, that they usually use the KNN algorithm. Perhaps I don't know if you know it, this algorithm, which is very well known in machine learning. And the other is based on models, in which we try to build a model. The system has a model about what kind of explaining the taste of the users. Okay, we have a model that obviously, as every model has parameters we need to find out, and this model is the base for providing recommendation. When we base on memory, when we implement a system based on memory, we have this architecture, so we have this process. But when we are working on a recommender system based on models, we have a new process called learner in which we try to find out the parameters of the model. So we have now two different databases, okay, for pedagogical reasons I include here in the slide. We have here a database, the previous database, and now we have a database in which we store the parameters of the model. And it's very typical here to provide matrix factorization, for example, in collaborative filtering. So, as previously, we have two kinds of recommender system. Now we have classified it according to the matching process. And we have a recommender system based on memory and recommender system based on models. And obviously, they have drawbacks and advantages. And when we deal about recommender system based on memory, the most important drawback we have is that they provide, this recommender system provide non-scalable algorithms. And so, well, it's very hard to use when we have a very big database. On the other hand, when we are dealing with a recommender system based on models, we have these systems provide scalable algorithms. However, recommender system based on memory has important advantages. So indeed, it's very simple to implement. And the recommendations they provide, they are very easy to understand and very easy to explain for the system. However, when we deal with recommender system based on models, it is very hard to understand and justify recommendations. So, well, this issue should be very well considered now, because researchers have focused for many years have focused on trying to improve the accuracy of the recommender system, and they don't consider other issues, for example, like explanations. So we have to try to develop models that provide recommendations that can be understandable. So we have here now that this question has been answered. So we have that the information that the database use. We know how to evaluate the recommender system, and we have we know now how to implement a recommender system, more or less. So the first question we should ask now is that we have these 4 kinds of recommender system depending on the input we have and depending on the matching process. And indeed, almost all techniques can be classified according to these 4 cells. Okay, for example, here we speak about Pearson correlation similarity function, which is here in collaborative filtering based recommender system, and which is based also in memory. And when we talk about recommender system based on context and based on memories, we have, for example, the TF-IDF technique, as you have heard of it. And when we speak, for example, about recommender system based on models and based on collaborative filtering, we have techniques like classical matrix factorization. We will deal in next lectures, and Poisson matrix factorization or binomial matrix factorization. When we talk about model-based recommender systems, which are based on contents, we have, for example, latent semantic analysis, probabilistic latent semantic analysis, on latent Dirichlet allocations. Many of these techniques are being used for information retrieval, for example, and we can use it to develop recommender systems. Obviously, there are hybrid methods that try to combine these 4 kind of cells. So we are going to start thinking about a collaborative filtering-based recommender system, which are based also on memory. So in this case, we have that the input of the recommender system is this table, okay, in which we express the rating that the user have made on the items. And just imagine that we have this user which has rated these items. Which item do you think that we have to recommend to this user? I7? I think I7 is not a very good idea to recommend it, because I think it's better to recommend I3 because other user has consumed the same kind of items and has evaluated very well this item. No? I7 is not a very good idea. Why is not a very good idea? You have observed that here users who have consumed, who has the same taste that the user U3 have rated with very low value this item, so it's not a very good idea to recommend it. And indeed, we cannot provide any recommendation about this kind of items. It seems that it's very hard to provide to predict the taste of this of the rating that the user will make to this item he consumed it. So the system predicts that the user U3 will like item 3 because other users who have similar taste to user U3 like this item. And this, as you can see, this information has only obtained with this table. Okay, we don't need information on items, we don't have information on users. Other kind of information, the kind of recommendation we can use here is, okay, I know that this user is a male, it's a boy, so just imagine what kind of items boys like. If we know that boys like crime films, perhaps we can recommend this item to this user. Or for example, if we have information on items, for example, that this item, that this movie is a crime movie, okay, and we know that this user likes crime movies, so we could recommend it. Okay, but here we don't know anything about the user and we don't know anything about the item. We only know what what the user has rated and what the other users have rated. And with this information can provide this recommendation. So this is the kind of an example of a recommender system based on memory and based on collaborative filtering. We're going to deal with a recommender system based on models and based on collaborative filtering. So now we have here to this architecture, we have included a learner process here, and we have here two important processes. The first one, the learner, and the second one, the matching process. Here in the learner process, we have two different kinds of database. Okay, in the first one, we have the ratings. That is because we are now here in collaborative filtering, we know that the input is based on the ratings that users have provided. And the model database is different. Now we have two tables, one related to users and another related to items. It's very typical. And here we have a factorization process, which is exactly the learner process, in which we build these two tables from this one, from the ratings. Once we have built these two tables, okay, this one, we can calculate the matching process. And it's very typical to use it in this way. We have a table of users, we have a table of items, okay, we know the features, we know this user, the code of this user, we know the code of this item, and we can obtain the features of the user, and we can know the features of the item, okay, because they are in the model database. And this score is usually calculated as the scalar product of these two vectors. This is very typical. Okay, is this number multiplied by this one plus this number multiplied by this one plus this number multiplied by this one. So we have the score of this value. So we have here the recommended system based on models and based on collaborative filtering. And we are talking about content-based recommended system which are based on memory. So here the most important issue we are going to consider is, I imagine that the recommended system is based, we need to recommend news, okay? So the idea of recommending news is, okay, I know that the user has consumed, has seen this news, for example, sport news, football news, or political news, or economical news, and I try to recommend, because I know that the user has consumed this kind of news, so I will recommend news about these topics. Okay? So the input here is the new, okay? And instead of considering all the text, because it's very hard for us to understand the text, for a computer it's very hard to understand it, we will use keywords, okay? We will store keywords and we will store the number of times that a keyword appears in an item. For example, here we know that in item E2 the term World Bank has appeared once. Okay? And here GPD, okay, this term, which is an economical term, has appeared in the item E2 5 times. So we have here now, instead of considering all the text of the new, we are going to consider a table related to items, which is contents-based information, in which we store the number of times each term has appeared in each item. Okay, these represent the items. And we also have a consumption table in which we store if a user has consumed an item. This is implicit information, implicit feedback. Okay, because the user has not rated the item, only has consumed the item. So we have now another table that is different from the previous tables. Now we have here that there are items in the rows of the table, and we have terms in the column of the table. And in each row, you can see the number of times that this term, that the keyword, has appeared in this item. As you can see, as in previous tables, this matrix is very sparse. Many words does not appear in the items because it's typical that the items use only a specific kind of words. Okay? So this is a content-based recommended system because we use information about the content of the items. And how can we recommend items to this kind of information? Well, here just imagine that we have this table, which is the item, is that a table related to the items, and we have here another table related to the consumptions that the users have made. As you can see here, this user has consumed item I1 and item I2. What recommendations do you think the system may recommend? I3. Why these recommendations? Because it seems that this item deals with the same topic to the item I1 and I2, and the user has consumed it. The user has consumed item I and item 1 and item I2. So, because this item has not been consumed by the user, and it seems that the user is interested in this topic, it seems that these recommendations can be given to the user. So, we have that here the system predicts that the user will like the item I3 because he has seen items I1 and item I2 that deals with the same topic to the item I3. As previously, we have some questions, some issues that we need to answer. For example, which is the similarity between items, which is the similarity between users in the previous recommended system, because we need to say, okay, this item is similar to the items that user has consumed. So this is the kind of things that we are going to do when we deal with recommended system based on contents and on memory. And we are going to talk about another kind of recommended system, which is this one, which is content recommended system based on models and based on contents. This is the last one. And we have here this architecture. And so here, as you can see, we have a process like the previous one. We have a learner process in which we have two databases. One is related to the model we are going to build. And here we have, as previously, the items, in which we specify the number of times that each term has appeared in each item. And we have a table related to the consumption of the item. And here, which is this table is related to this matrix we have seen previously. And here we have that there are three tables. One related to the terms, another related to the items, and another related to the profile of the user. So from these two tables, we are able to build three tables, one related to items, another related to the profile of the users, and another one related to the terms, the keywords we have used. Indeed, we only use these two tables, and this one is used for when you will see it in the next lecture, that this table is used to build rows here when we have new items. So the matching process now is the following one. We have a user, we have an item, and we have, because we are building in the model database, so we have this table, and these two tables are used to calculate the score of the item. And it's usually calculated as the scalar product of these two vectors, although it depends on the technique. Okay, but it's very typical to calculate this score by means of the product of this value to this value. We plus the multiplication of this value with this value plus the multiplication of this value with this value. So this is the score of the item 3 for this user. So we have seen these four kinds of recommender system, okay? And there are obviously hybrid methods, okay, to build recommender system. Okay, so in this kind of recommender system, we have information on items and information on ratings, okay? Just imagine that we have this kind of input in the recommender system. So we work with this input. This table is related to content or collaborative information. This table, which one? It's related to what is going to see you? Content-based information. It's content-based information because here we have here items and we have here terms. What I have used, I don't know if you know it, but you have here, I don't know if you know football. Because here Real Madrid, here is Football Club Barcelona. It's very, I know that it's their national sport, but I don't know any team, or so I cannot use it. And here is a very important football player, it's Cristiano Ronaldo, okay, and here is ball, Okay, and here is related to economical terms. I suppose you know it. You know these terms, or tax, for example, APR, euro is the currency of Europe. And here we have, because I don't know the political parties in your country, I have used my political the name of the parties in my country. So here you had vote, poll, and president. So we have 3 different kind of topics. News can be in this kind of topics. So we have here information on the items. And here we have information on the ratings that the user have made, because here we have that the user, now we have, here we have represented the transpose of the previous matrix. We have the user U1 has rated the item I1 and the item I2 and the item I3 with the values 5, 4, and 5. So the recommended system now will use these both tables to provide recommendations. Can you see it? Okay, very well. So here, for example, we are dealing with the user U2, so we are interested in this column. Okay, so we know that the user U2 has rated the item I1 with value 4, and the item I2 with value 5, and the item I10 with value 1. Can you see it? And so here we provide the following recommendations. The item I3 is very typical. The recommended system has been well developed. This will be the recommendation. Why? So there are 2 important reasons to predict this item. The first one is because the user likes item 1 and item 2, and these 2 items deals with the same topic to item I3. Another important reason to recommend this is because other users has consumed this item and like it. Here we have that there is one user, U1, who has consumed the item E3 and has rated with a high value this item. So we have 2 different reasons, one for collaborative, another for content, for recommending this item. Can you see it? Okay. Just imagine that we have 3 new items. So in this case, you can see that we have information on the content of the item, of course, because we know the new. We know the keywords that appear in this new. But this item has not been rated, or if it is rated, it is rated by very few users. For example, here we just imagine that it has been only rated by the user U2. So in this case, the recommender system can recommend the item I1 and the item I9. Why? Because, well, you can provide these 2 recommendations, I1 and I9. We are going to explain the recommendations. In the item I1, why do we recommend item I1 to user U3? Item I1 is very popular. As you can see, it's very popular here. Everybody seems to have rated very high. So, for collaborative filtering reasons, we can recommend this item to the user U3. Okay, so you can see that this user, all these users have rated very high in this item. However, as you can see, well, I think that this user, the content-based recommender system cannot obtain these recommendations. Why? Because if you see the items that the user have consumed are not similar to the item we are going to recommend. So a content-based recommender system cannot provide these recommendations, and it seems that it's very interesting recommendation because many users have rated. So according to this table, we can provide this recommendation. And the item I9 is also recommended to user U3. Why? Because here I9 deals with the same topic to the items that user has consumed. So we have here that the user has consumed these two items and are very similar to the item we recommend. This is the reason why we recommend the item I9. And this is a content-based recommendation. And indeed, a collaborative filtering-based recommendation system cannot obtain these recommendations. Why? Yes, because nobody, any user, has rated this item. So according to this, according to this table, we cannot provide any these recommendations. So here is the reason why this is a novel, a completely new item. We can recommend it to our users, to a user. There are two filtering processes. Yes. The first one is not very important, indeed. It depends on the domain. Just imagine that we want to provide recommendation on movies. It's very typical to provide recommendations. The recommendations here are not items that the user had consumed, for example. Another example is what I have talked about, recommending restaurants. If I'm in a city, you cannot recommend a restaurant which is in all other cities, in other towns. So here, this process only filters the items that are close to the user. So this is the filter. And this filter, this one here, basically select the item with highest scores. But this filter depends on the domain, so it depends. There are, for example, geographical recommender systems. So, but the most important process is here, this one, the matching process, because it's very simple to implement. And this is very simple to implement also. So it depends, this one, this matching process, which is important to remember that is a function that in which a user, an item, input, and outputs are a score value, indicating that the user, the value, how much the user likes this item. Okay, this is the matching process, and depending on the kind of recommended system, we will have different kind of matching process.